Did you know that about 50% of a home's air conditioning load is due to solar heat gains through windows? And that also has a big impact on comfort. Now the size, the area, and the orientation of glazing also has a huge impact on the size of an air conditioner. With me today is Ken Nittler, who's developer of MicroPass energy compliance software. Ken, what impact does the area of windows have on the size of an air conditioner?
Well, Steve, windows have the biggest single impact on the size of air conditioning equipment. Most people would be surprised to find out how big it is.
Do you have examples?
I do. The first graph here is a pie chart, pretty easy to understand. What we have here is a home in climate zone 13, which is Fresno, very hot climate, and we're looking at the design cooling load. And when you break down where the heat comes from that your air conditioner needs to run to remove, what you see in this particular example is a case where glazing is accounting for 54% of the design cooling load.
What type of glass is that?
This is a case with the prescriptive package glazing, which means it's a low solar, low E glass. So this is the good stuff.
What if it's standard double pane glass?
Well, I did that with this same exact example and was up at 63% of the cooling load was due to the impact of the windows.
How much can we typically reduce the size of an air conditioner?
Well, I have another slide that illustrates that. This shows some of the same data, but on the vertical axis is the cooling load in BTUs per hour, and across the horizontal axis is which building component is causing the heat gain. And you see that second bar there where it says glazing, and the numbers come in the 13,000 range. That same house, except with clear glass, the cooling number for the glazing is up at 22,000. So if you did the math on that, you're saving about 9,000 BTUs per hour. Now, as a practical matter, most air conditioners come in, the correct metric is called the tons of air conditioning, and typically you can get sizes at about the half-ton mark. So in common practice, that might mean you could downsize the air conditioner about half a ton. The reason that's so important is that in order for utilities to cut back on our peak demand, which is where most of our problems have been in the last few years, we need to downsize or correctly size our air conditioners so that when people come home from work and flip on those air conditioners, that we don't overtax our energy generation system.
That also impacts how long the air conditioner will last and how efficient it is?
Yeah, it turns out unlike large cars where most consumers bigger is better, the average consumer is going to be better served by having a smaller sized air conditioner. And the reason has to do with their operation. When you have an air conditioner that's oversized, it cycles. It turns on, it turns off, it turns on for a couple minutes, turns off. Whereas a smaller size air conditioner runs more consistently across the hour. And it turns out it's more efficient when it runs for larger run times. What
about comfort?
The real reason we all have air conditioning is comfort. And after all, without the invention of air conditioners, many of us would not live in inland areas. One impact of windows and window area, we all know from personal experience that on a hot summer day, you don't go sit in front of a west window. And you know that because you feel that radiant heat gain. And even at times when you have proper air conditioning, sometimes you can be uncomfortable when you're in front of that window, even if the air temperature is okay.
What is the difference in surface temperature between the spectrally selective low E glass and other types of glass?
What I have here is a chart that sort of illustrates if you have a dual glazed window and you have the sun shining on the window, and let's make up some typical conditions. Let's say it's 100 degrees outside, 70 degrees inside. And you ask the question, what's the surface temperature at the inside of the window? Well, on clear glass, under those circumstances, you'd see an inside surface temperature of about 90 degrees. That'd be clear dual glazing. We're now moving to a market where the low solar gain, low E, is going to be used in increasing percentages of homes, especially in the cooling climates. And for the low solar gain, low E, that same surface temperature is about 82 degrees. You know, pretty simply, you'd rather sit next to that window that's 82 degrees than a window that's 90 or even 100.
What about tinted glass? They always seem like they radiate a lot of heat.
Yeah, well, tinted products have even higher surface temperatures. A bronze tint. Keep in mind that the tinted products work by absorbing the heat. So by design, the glass heats up and some of that radiant energy comes into the house. And the inside surface temperature on a bronze tint dual glazed window might be as high as 97 degrees.
Wow. Great information, Ken. Thanks.
My pleasure, Steve.